Now in this problem it says prove that the squares of all terms of the arithmetic sequence 4, 7, 10 belong to the sequence. So our sequence is 4, 7, 10. The first term is 4, the difference is 7 minus 4, that is 3. That's our formula. We substitute the numbers into the formula and then we simplify. So we get 1 plus 3n as the formula for the nth term. Now squares of all the terms, that means 4 square, 7 square, 10 square should also belong to the same sequence. That's what they are saying. So let's do an square. So 1 plus 3n whole square, we'll use the formula for a plus b whole square. And we can open the bracket, it will become 1 plus 9n square plus 6n. Now to match with an, so what we are doing is we are taking this 9n square and 6n, we are taking 3n common from it. So when you take 3n common from it, we will get 3n times 3n plus 2. Now if we compare an and an square, we can see that n times 3n plus 2 would be a whole number. We know that because n is a whole number. N is the number of the position of the term, the first term, second term, third term. So that this thing which is there in this blue box will be a whole number, which is same like the n in our formula for an. So that means an square can also be written as 1 plus 3n, that is 1 plus 3 times the whole number. This proves that an square will also be a part of the sequence. Then the next one, write 3 arithmetic sequences with 30 as the first sum of first 5 terms. With 30 as the sum of first 5 terms. So first we'll write the formula for the sum of n terms. Then 30 is the sum of first 5 terms. So terms, that means Sn is equal to 30 and n is equal to 5. Then we simplify this and we get this equation 6 equal a plus 2d. Now we have to check with different numbers. So for the first sequence, I'm going to take a as 2. I cannot take a as 1 because if I take a as 1, then d will come out as a decimal number. So I'm not taking a as 1. I'm taking a as 2. Then I substitute that. I get the value for d as 2 and then I create my sequence. A is 2, difference is 2. So 2, 4, 6, 8, 10. That's the first 5 terms, and if you add it up, it will come out to be 30. Similarly, for the second sequence, I'm going to take a as negative 2 and repeat the process to get d. Then I create the sequence. So first term is minus 2, then minus 2 plus 4, which is the difference, will give me 2. Then 2 plus 4, 6, 6 plus 4, 10, 10 plus 4, 14. Again, I can check whether I get first 5 terms, if I add them up I get 30 or not. And similarly for third sequence, I'm going to take a as 4 and repeat the process. I get the third sequence. Then the last question, the first term of an arithmetic sequence is 1 and the sum of first 4 terms is 100. Find the first 4 terms. So the first term is given, the sum for the 4 terms is given 100. So we write the formula for Sn. Substitute the numbers which we have got. So Sn is 100, n is 4 because it's the sum of the first 4 terms, and a is given to us, the first term is 1. We can simplify this and get the value for d. D is equal to 16. Now we need to just generate the first 4 terms. So we write the formula for an and substitute it. First term we already know that it's 1. Then for the second term we'll replace n by 2 and simplify to get 17. A3 will be 33 and A4 will be 49.